Okay, let's jump right in. Welcome, everyone, to a bit of a deep dive today. We're looking at some really fascinating source material that you brought to us.
Yeah, it's quite intriguing stuff.
It really is. It connects some dots in ways I certainly didn't expect, linking areas you might not think belong together at first glance.
Absolutely. And what's really striking, I think, is finding these, well, unexpected intersections. Your sources lay out a pretty clear line between uh, the mathematical concept of differentiation,
Right, calculus stuff.
exactly,
Yeah.
and something as, practical and vital as food security.
Yeah. And it gets even more specific, doesn't it? Your material really zeroes in on one particular aspect within food security.
It does. It talks about the sensitivity of pH, specifically in fermentation processes.
Okay, so our mission really for this chat is to explore that specific connection, the one highlighted right there in your sources.
And maybe understand why it's particularly relevant, especially perhaps for you if you're, say, a college student just getting into differentiation and integration.
That's a key point the material makes, right?
That's absolutely right. The material you provided, it makes a very explicit statement. It points directly to this relationship
Okay, so the relationship is math differentiation relevant to pH sensitivity,
within fermentation.
all under that big important umbrella of food security.
Precisely.
And here's something I found really interesting. Your source doesn't just mention this casually.
No, not okay.
It specifically flags this connection, this link, as being, well, highly suitable for college students, the ones actually studying differentiation and integration.
Exactly. It literally points to pH sensitivity during fermentation as a key sort of real-world scenario.
A scenario within food security.
Uh-huh. Where, according to your source material, the principles of differentiation are relevant. They play a role.
So thinking about what differentiation actually does in math, it helps us look at rates of change, how sensitive things are.
Right. How one thing changes in response to another. That sensitivity aspect is key.
So your source is suggesting that this mathematical way of thinking applies to understanding pH in fermentation.
That's the idea presented. That this lens helps understand how pH behaves and why controlling it so carefully is, well, critical for food safety and quality.
So it's not about us diving into the specific equations right now, because the source doesn't actually provide that level of detail.
No, it doesn't give us the formulas. It really just focuses on highlighting the existence of this connection.
Okay, so what this shows then, pulling directly from your material, is that these sometimes abstract-seeming math ideas, they're not just stuck in textbooks.
Not at all. They can actually pop up in really crucial scientific processes.
Like making sure fermented foods, kimchi, yogurt, that kind of thing, are safe and stable.
Exactly. Your sources are basically holding this up as a tangible example, a way to see concepts you might be learning in class.
Like differentiation, measuring sensitivity.
Showing up in the real world, impacting our food supply. It's about recognizing the connection exists and that it's seen as a valuable illustration for students like you.
It really demonstrates, yeah, one surprising place where a concept like differentiation shows up in the science behind fermented foods, which connects directly to food security.
And it reinforces that this insight, this specific link, comes straight from the information you provided.
Yeah,
They're focusing only on what that material highlighted.
it really does. It kind of makes you stop and think, doesn't it?
Hmm.
Consider all the other places where these seemingly abstract math concepts might be lurking.
Yeah, like differentiation showing up unexpectedly. In this case, ensuring food quality and safety.
Makes you wonder what other surprising connections are just waiting out there in fields you wouldn't even think to look.
That's a great question to ponder. What else is connected in ways we haven't seen yet?
Definitely something to chew on, as they say. Thanks so much for bringing this material forward. It was really thought-provoking.